And welcome to episode 49 of the Actual Astronomy Podcast, your guide to observing the Mars 2020 opposition. I'm Chris, and joining me is Shane. Say hi, Shane.
Bonjour.
We are two amateur astronomers, and that means we do astronomy just for the fun of it. And this podcast is one of the ways we get to share our love for astronomy with anybody who wants to learn more about the night sky. And this time, we're going to talk about the Great Mars Opposition of 2020. So Shane, what are you doing on October 12th?
Well, the obvious, I'm eating
Gonna
turkey.
be complaining about all the clouds.
It's Canadian Thanksgiving. We're eating turkey that day.
And it's the Great Mars Opposition for this
And
year.
that too, yes. Yeah, it better not be cloudy.
Yes.
Better not be cloudy.
Better not be. Basically, this is going to be, and leading up to it, like it's not just the 12th, but really from now, we're just about a month before the 12th of October and the month after. This really is the time to take a look at Mars. In fact, I was out this morning. I got up, as you know, I get up at 3 a.m. and go out and see if the conditions are good enough to observe. And they just weren't quite good enough. There was some cloud actually, but Mars is now so bright that it was beaming right through the thin cloud that was up there. It was like the only thing I could see in that part of the sky. And it was super visible. In fact, at first I was like, I'm going to grab my gear and bring it out. But then I realized it was just coming through the clouds. And it is that bright.
Wow. Well, it's incredible. It's just a beacon in the sky. And what I love about these good oppositions is, just how orangey it is too, even to the naked eye. Like you just can't mistake it.
Yeah. So how often do we get these oppositions in general?
They're about every 2 years. I believe it's 26 months-ish to be
like
exact.
Yeah.
But every 2 years, Mars becomes, or it gets much closer. It's not what's the right word here? It's an elliptical orbit. So the distance between us and them, or it,
little foreshadowing.
It's not elliptical. There. Yeah. Okay. Let's carry on with the script.
Yeah. No worries. So not all these oppositions are created equal. I think what you're trying to say is there's basically some oppositions where Mars is closer to us, and there's some oppositions where it's farther away. And then as well, there's oppositions where it's further south, because the ecliptic runs through some of the southerly constellations like Scorpius and Sagittarius, and it's very low on our northern horizon. And then there's times like this one where it's really nice and high. So there's several factors there. So sometimes it can be nice and high and be far away, and sometimes it can be nice and close but too low down. And when it's low down, the atmosphere impacts it and really impedes our view. And when it's far away, that the planet is very small. But this is one of those ones where it's both very high in our nighttime sky. Boy, like even this morning, I was out a little bit later, and it was at 5 o'clock, and it was still up like maybe 50 degrees in the nighttime sky or something like that. So really nice and high, and it's really close. And I was looking, and the next really good opposition for us in the Northern Hemisphere anyway is not until 2034. So we got more than a dozen years to wait for the next one. Unfortunately, that will be this good. Now, even though it comes around every 26 months, the next one that would be this good is some time away.
Yeah. And one other thing that you and I have talked about on a few of our previous podcasts is the last Mars opposition was almost like it really wasn't worth observing because a dust storm had taken over the entire planet of Mars. So there was no surface detail to see. It was just this orange circle.
Yeah.
Right now, there's no dust storm happening. Now that could change. It's an active planet in that regard. So, the other part of this is like, you got to get out there and observe it as much as you can, because tomorrow a dust storm could start to kick up, and then a week later you won't be able to see any detail on the planet. So the next 2 months, I'm going to be looking at Mars every clear night that I can, because of all of these factors. It's just things are lining up right now for it to be an outstanding Mars season.
Just after the pandemic hit, and with this Mars opposition coming up, a couple of my friends were giving from Ontario. They were giving a presentation, and they took it on to Zoom. It wasn't supposed to be on Zoom, so I attended it. And they had actually made this big plan for the 2018 opposition to finally go down, and they had a bit of a sponsor. In another mutual friend, or from another mutual friend, who arranged for time on the Lowell Observatory Clark telescope, and they went down, and I feel really bad for them. They went all the way down there, and they were dust stormed out. They actually had like 3 nights booked where they were the only people there at the telescope.
Wow.
And it was clear on Earth, but not clear on Mars. And there was like one night where they could just barely see some of the features now, like not even as good as the other night when we were out, and we had some poor seeing conditions. They weren't even able to see it that well. I felt pretty bad. They had like kind of arranged and spent a lot of money for that, but and you know, that just can be the way it is. But the whole experience, they had a lot of interesting stories just from the whole experience, and being there on Mars Hill, where Lowell made his sort of famous, or perhaps infamous, observations, is pretty cool. So Shane, what is an opposition exactly? We're saying Mars is going to be an opposition on October 12th. So what is an opposition?
So whenever we talk about planets, we often circle or focus in on opposition. So within astronomy, opposition is when 2 astronomical objects are said to be in opposition when they are on opposite sides of the celestial sphere, as observed from a given body. So that would be Earth for us. A planet is said to be in opposition or at opposition when it is opposite to the sun in our skies. So this means it rises at sunset and sets at sunrise, so it's visible for the entire evening.
Yeah, and kind of leading up to that, and you made a bit of a joke, but it's true that I've sort of become a bit of a nocturnal creature, because before opposition, it's highest in the morning sky, and then after opposition, it's highest in the evening sky. And the one thing that I've found is that the morning sky can be a little bit more stable and a little bit clearer than forecast. Even this morning, wasn't supposed to be clear when I first got up at about 3. It was completely cloudy. I was chatting some astronomy with a friend of mine on the West Coast. He was also clouded out and smoked out. And then when I went outside at 5, it had almost cleared off, but we had some unexpected rain overnight, and the skies were very, very humid. There was a lot of moisture around. So I didn't set up. But once we get past the 12th, I'll pretty much just be observing in the evening sky. Unfortunately, because I think those morning skies really are. I think you should at least get up once and do a morning session, I think.
One of these days I'll shock you and actually do that. But, I won't make any commitments at this point in time.
Oh, good stuff. So what captivates humans on the pale blue dot, which our Earth sort of was named by Carl Sagan? So what captivates humans so much on our planet about the little orange ember up there?
Well, I think there's a couple things. Like, one is it's a challenging observation because it's a long ways away and it's not a very large planet. But it gives you just enough detail that it can, well, in the past, it's certainly spurred a lot of imagination around what people could be observing. But I think the other thing that intrigues people a lot about Mars is there's a lot of similarities to Earth. You know, it has polar caps. It has deserts that we're aware of, a large volcano. There's a lot of similarities to our home planet. And you can tease some of that stuff out, even with the small telescope. Like my little 76 millimeter the other night when we were out, the seeing was terrible, but I was still able to, detect kind of the white attributes of the polar cap, as well as some of the darker features on the surface, like some of the desert regions. Like I think I was getting glimpses of Syrtis Major, I think.
Oh, wow. Well, that's awesome.
Yeah. So certainly, that stuff makes it a very interesting object to observe. And then, like we mentioned, like it only comes around every 2 years when it's a good target for us to look at. So some of it is supply and demand. I think that makes it a very intriguing object to look at.
Yeah, and kind of like what you're saying, I think just the idea that it does have these polar caps in the areas that were once thought to be seas and continents, like you were mentioning, Syrtis Major, which kind of is like this Africa-shaped continent-like feature, really kind of makes us feel like we're looking at a planet that is maybe much more similar to Earth uh, than what it actually is. So these ideas were really solidified in the 1800s by an Italian astronomer called Schiaparelli, or named Schiaparelli. And his impression was that these channels appeared like a spider web across the surface. And then it was the American Percival Lowell, who we kind of referenced there a few minutes ago. And he erected an observatory in Arizona, just outside of Flagstaff, and he called it Mars Hill. And this really fostered the idea and perhaps created a now widely held myth of Martian built canals that were channeling water away from the melting polar caps to save the parched inhabitants of the deserts. Like it really makes a nice narrative. Now, what I think happened was just prior to this, in 1877, a guy named Asaph Hall, who was an American observer at the U.S. Naval Observatory, former teacher, he discovered these two moons in orbit around Mars. And boy, they were really small and pretty difficult once they did the math. They were captured asteroids. And I think there was really a feeling that sort of like sky's unlimited thinking. Anything is possible to observe, so that if you are observing these things on Mars that are right at the limits of what's possible for a human to perceive through a telescope, that there actually is a lot of merit to them. Now, Hall was truly an astounding visual observer, and unfortunately, I think a lot of the others were just misinterpreting or misseeing what was at the very, very edges of their the perception of their eye, unfortunately, and that's what they were seeing as the canals.
Yeah, and to observe Mars's moons is incredible. Like, not only do you need to be an outstanding visual observer, but you need the right conditions as well as the right instrument. Those are not. I've never seen them. I don't know if you've ever visually seen them.
No, I never have. I know a couple people that have been able to, and you need some very specialized equipment, and an occulting bar, a large telescope, excellent conditions. Mars needs to be close and high up like it is this time. Yeah, you need lots of stuff to be lining up in order to make those. And Hall was observing in a bad spot in where the U.S. Naval Observatory was at the time. Anyway, I'm not sure if it's still there. Is called like the Foggy Bottom or something like that. Like it's in this low area that's prone to fog. And anyway, so he just sort of waited out and was observing during the best times with some of the best equipment. So that's really what came down to. So yeah, it ended up being one of those things where there was a lot of sort of public misconceptions about it, and then that kind of got a little bit carried away. But since the 70s, we've had spacecraft touch down. I think the Viking lander touched down. Sort of before the time where I would be watching much of anything in the 70s, and there was a couple of those landers, and then we've seen lots of rovers recently.
Yeah. And I'm just reading here about Mars 3
Okay.
from the Soviet Mars program in 1971. It looks like Mars 3 maybe was some kind of probe that orbited Mars, and then Mars 2 was a lander that crashed. Oh no, Mars 3 lander became the first spacecraft to attain a soft landing on Mars.
Oh,
December 2nd, 1971.
wow.
Although it failed 110 seconds after landing, having transmitted only a gray image with no details. Very interesting. Yeah.
And we've had lots of rovers. Like I remember in the late 90s, we had some sort of remote control car-sized rovers that I think were still tethered to the original spacecraft, and then we sort of moved up to the like Opportunity class rovers that were sort of ATB sized, and then I think eventually like the Curiosity, and now the Perseverance rover, which is on its way in. And it's about the size of a small car, like 10 feet long, 9 feet wide, 7 feet tall. It's about the size of a little car, really.
Yeah, yeah, and it's amazing what Curiosity has sent back to Earth for research and data, like just phenomenal photographs. And one of my favorites is oh gee, it's like just kind of capturing the horizon and a sunset on Mars. You know, it just feels very natural, you know, very Earth-like.
Hmm. And of course, we have a little bit of a connection here with the landers on Mars, because the NASA team was trained by someone from Regina, Saskatchewan, and how to do that. And from time to time in the past, we've actually had some of the NASA team come up here and give presentations, which has been really cool, because sort of Saskatchewan was one of the leading places for aerial and satellite geological exploration, where they were one of the first places to take satellite and aerial images of the geology of terrain in order to figure out best mining and forestry practices and stuff like that. And then when NASA was looking to actually put landers on Mars, they needed that expertise, and so they came here to be trained on where to put a lot of these Mars landers down. And I kind of heard that and was a little bit skeptical about it. And then we had Jim Grace come up, and I got to have some meals with him and spend some time. It was pretty phenomenal, to be able to do that.
Yeah, yeah, absolutely.
So the geology of Mars, sort of as a bit of a segue into what we were just saying, there's no plate tectonics, but there is some volcanism there. In fact, the largest volcano in the solar system, Olympus Mons, is there. And it's so large, it's sort of hard to get your head around. And like you and I have both been to some of the large volcanoes on the Hawaiian Islands, but Olympus Mons on Mars is so huge that if you landed on it, you would barely be able to perceive the grade. Like, it's so gradual, and like that's how large it is, even though I forget how high. It's miles and miles high, though.
It's 21 kilometers
21
tall,
kilometers
which
tall.
is 13.6 miles. So, and just to put some context here, so we're all familiar with Mount Everest, tallest mountain on Earth. Olympus Mons is approximately 2.5 times Everest's height above sea level. It's incredible. Like, if that was on Earth, the peak of Olympus Mons would be, I think, extending into space. Like, I think that would poke through our atmosphere.
That is amazing.
Mm-hmm.
Now, Mars itself, one of the things is, and people often say, well, like, would you go to Mars? Like when I'm doing a talk or something, or I know when Jim Grace was here doing his presentations, that was one of those things. And he was like an astounding no as well, if I'm recalling correctly. And one of the reasons why is that, Mars is much smaller. Like when you look at it, yeah, it's round and it has some atmosphere and it has these polar caps and these desert and continent-like regions and large surface features, which are very reminiscent of the Earth. But that's kind of where it stops. Like, it's actually much closer in size to our moon than the Earth itself. I mean, it would be amazing if it was the size of the Earth. It would be amazing what we could see there, but it's just not.
It is small and it is a long ways away, which makes it challenging.
Yeah. So a little bit more on the history there. Like, you can see these polar caps, which we've talked a little bit at, and they have some water ice in them and some carbon dioxide ice and other subsurface ice. And these were first observed by Huygens, Christian Huygens, back in 1672, and then later confirmed by Maraldi in 1719. There's also a lot of caves and valleys that have been discovered by the Viking and Mariner missions and such, and they were carved out. They now think, and this is sort of like recent stuff I was reading just over the summer, where they think there was these large glacial caps, not like a global snowball or anything, but there was some large glacial features, and that these melted at one point, and then the melt happened very quickly, and it sort of forged out features like the Mariner Valley. I don't know if you read any of that stuff this summer when they released a few papers on this. They had some really neat shots showing like Mars and then like these glaciers and then like how it kind of carved it out, and then those features kind of filled back in with some ice and water and that sort of thing. It was really cool.
Yeah, that is very interesting.
There's also very little magnetism on Mars, and this is definitely a problem for anybody that has thoughts of going and wandering around on the surface, because that means that the solar wind and the weak gravity, because it only has about 60% of Earth's gravity, the solar wind is pushing the atmosphere out into space.
Yeah.
So that's a problem.
It would be a very challenging place to have a good life, I guess.
I think so.
Yeah.
It's definitely a problem.
Yeah. It's very interesting, like the whole concept of, people going to Mars, and maybe at some point, the talk about like actually thriving or living on Mars is incredible. The fact that some of those plans, that we may actually see a person on Mars in our lifetime, I think is so exciting.
That would be exciting. I'd be very concerned for that individual.
Well, they're not coming back, I think, would be one of the key things, right? They're going there to do work and be a pioneer of sorts, but we're probably not seeing them back on Earth.
I know, and I think like I would struggle with that, like sending somebody off to their imminent doom. I just have a little bit of a problem with that. Sort of working in scientific research, I do have a little bit of a problem with just I think ethics would have trouble with that one. Like so that person's gonna, I don't know. I think a lot of things would have to line up for that to get approved. I also think like sending somebody there and having them come back. Yeah, I don't see that as an insurmountable challenge. But I think like if we did send somebody and then, eventually they get into trouble, I think there would be a pretty big rallying cry to kind of go and save them or whatever, because, that really is sort of a very bad situation, nobody wants to see, right? So I think they got to figure out a way to get them back if we're going to send them.
Yeah.
All right. So what can we actually see? So what can you see, unaided eye or naked eye?
Without like any optics?
Yeah, without any optics at all.
Well, it looks like an orange star to me.
Yeah.
A very bright orange star during this time of the year, or like this opposition.
Yep.
But that's probably about it, I think, unless there's other things I'm not aware of.
Well, there's and that's all you can actually see of the planet itself. But this was something, Mars was something that people were watching for many thousands of years. And the one thing that they noticed is that there's a period of time where it does a bit of a loop-de-loop, basically. And nobody understood why until about 1600. So there was a lot of theories. And of course, we had the Copernican theory come along in the 1500s when Nicholas Copernicus put that out. But still, even with the Copernican theory, nobody could really explain why Mars did this loop-de-loop, or basically what it does is it does this backwards, or what's called a retrograde motion. So, and you can see this even without a telescope. And what you'll actually see, and the person who made the best observations of this and was Tycho Brahe, he was observing before the telescope was used in the nighttime sky. He's observing in the mid to late 1500s. And he made all these observations of Mars and this backwards action against the star field. So what happens is you see Mars going along at this time, and then there's a point. I forget when that point is exactly. I don't know that it necessarily lines up with the opposition date. But around now is when you'll start to see this. You'll see Mars will actually stop. So it's trucking along. The stars are kind of going past Mars as it's going in its orbit. And then it sort of appears to become stationary. And then it changes direction for a period of a few days or weeks or whatever it is. And then, kind of starts to reverse direction again and then continue along its path against the background stars. and nobody could really figure out this. But Tycho Brahe had an apprentice, or maybe that's the wrong way to put it, but was Johannes Kepler. And he created a mathematical model, which we rely on today for these orbital dynamics. And he figured out the business of retrograde motion or retrograde action. And basically, and look, I'm no math major on this, but the best way I've seen it described, it's like two cars traveling. And imagine you're on a multi-lane highway and you're in the rear car and you're approaching a car on that highway. So you actually will see that car traveling along, maybe in the distance as you're approaching it. And just like you, the trees are kind of coming up to that car and going by on sort of one side. And that's what you would expect. Now, something that most people may not have quite noticed, especially if you're the driver, you should keep your eyes on the road. But as you approach that car and then pull out to pass, those trees will appear to move in the opposite direction, just as you're going by the car. It's just a function of perspective, where you are, and the motion of that vehicle appears to actually go backwards because you're passing it, right? So you're going to see that car sort of moving into a position behind you, and it's that motion which appears to make the car move backwards in relation to those trees, like sort of in the far background. And then once you're past, it will begin to very quickly move along in the same direction you're going again, and the trees and everything will continue to sort of move past as you would expect. So that's basically what's happening with Mars. As we overtake it, we're on the inside orbit, so we're moving along, and we see Mars in the sort of distant sky because it's outside of our orbit, and it's passing stars. And then as we come up and we're sort of lining up just right with it, we'll see it stop. We'll see it move backwards as we pass it, and then it stops and changes direction again and continues on that regular motion. So you actually can see this, and this is one of the things that they say you can see with the unaided eye, and that's how it was originally observed.
That's very interesting. I was
Yeah,
not aware of that.
yeah, it's you kind of would have to go out and plot it night to night. But
Yeah,
I've never really done that, but I've heard of other people that are really into, say, like some people might be more into the math of all this. And I've heard of people like kind of running the numbers and then going out and watching it, kind of getting some enjoyment out of that. That's a little bit beyond my mathematical skill level, though.
yeah. Well, I just like to look at pretty things.
Yeah, me too. But you might be able to see this a little bit better through binoculars. And I think with binoculars, you might be able to see a bit of a disc, especially this time. I think before might be a stretch to say you see a disc. I think you could see a disc this time with Mars, and then you would be able to see it kind of go by the stars, especially like week to week. You're going to notice a change in relation to the background stars. And if you kind of look for the Mars retrograde orbit, you'd be able to kind of track it in amongst those stars, and that could be kind of cool.
Yeah, well, and binoculars would be great for that observation just because of the wider field. Like you would require those background stars there in order to achieve this observation over a period of a week or whatever time frame it is.
Yeah. Now with a telescope, that's a whole different ballgame.
Yes.
So what can you see with the scope, Shane?
Well, I think the most apparent things people will notice through a telescope will be the polar caps, if they're visible. Because again, with that orange planet and then the white cap, there's such a contrast there that they jump out. Even the other night in really bad seeing, I was able to see like there was white on the northern polar cap, and you couldn't miss it. And then the other things is you'll see kind of a contrast on the surface between darker and lighter colored or brighter features all across the disk of the planet. Now, what you see there varies greatly on the seeing conditions as well as your aperture and maybe even some of the filters that you use.
It's really amazing to see these polar caps through the small telescopes. Even through my 60 millimeter this year, I've been watching the south polar cap shrink, especially as the planet Mars goes into its late spring and summer months here, and it becomes more tilted towards the Earth. The south polar cap, I'd missed a week or so, and then when I went back out, and I guess it had rotated around enough that at that point the south polar cap appears way out in the desert because South Pole is tilted so far towards the Earth now, you can actually see right around the pole, which is really amazing. And I think we're just having a good opposition, and it's just a good time in the Mars seasons to be able to see this. I was really blown away. I just thought that I must be making some sort of observational error at first, and then kind of went and looked at the orbit and the angle and the inclination and all that, and I was blown away at how far that south polar cap was sort of onto the disk. Like, you could see an appreciable amount of desert beyond the cap, in what I thought would be the polar direction. But it's just because the pole is tilted so far towards us. And then in the north, originally I could see a bit of the north polar cap, like itself. But now, almost like what you were saying, is there's so much snow and ice and everything that's formed up in the North Pole during the winter now, that you're really just seeing like a huge area that has sort of been covered in frost and snows and ice and all this other kind of material, and that's built up. So originally, when this opposition started here a few months ago, and I was looking, the North Pole, when you could see it, really just looked like a large kind of polar shaped feature. But now that whole area is covered in like a bit of a snow cap, really, more so than just like a round circular polar cap, like you might traditionally think of one. And my observations, again, like I was kind of questioning them, and then I was talking to some other observers online, better observers than myself, like Richard Schmoody, and he and I had a good conversation about like how big that cap was getting, and he had made some more accurate drawings than what I had made, but definitely my observations were concurring with his, and it just goes to show like the experience of taking a look at some of these things.
Yeah, and Mars, like it's very dynamic in terms of its seasons and how the polar caps in particular evolve or change during that time, which is another reason to observe Mars many times over the next couple of months, as many times as you can, because you'll see some of this stuff change over the coming weeks.
Yeah, and it was Christian Huygens who first saw these Syrtis Major feature, like the dark African-shaped continent, in his sketches, and he was using an aerial telescope. So he was using, I think it was like a 2 or 2.5 inch telescope, but I forget how long it was, like 28 feet long or some sort of ridiculous number. So I was thinking, no Burleback chair for him, Shane.
Yeah, poor guy.
But sort of speaking of gear, the higher quality equipment, and sort of almost irrespective of size, is what will help reveal some of these fine details. In fact, probably it seems like about the ideal instrument for observing Mars seems to be like about a really good 8-inch or so reflector. Really seems to be happy size.
Yeah, I used to have an 8-inch reflector, and I've had some outstanding observations of Mars with that. But you know what, I struggle a little bit sometimes with having too much aperture with the planets, and in that some of the brightness washes out some of the subtle features of the disk. So, I'm a little bit on the other side of the spectrum, where I would almost prefer what probably most people would consider an instrument that's just too small. Like my 76 millimeter, the last Mars opposition, I was using a Tasco 7 TE5. So that's a telescope from the 60s. It was a 60 millimeter telescope with a really long focal length.
Yeah.
But because there's less light coming through the telescope, I kind of believe you can see some subtle features that probably are washed out by larger apertures. Now, larger apertures do show some other features better. Probably, Syrtis Major is probably more defined, and some other things will pop out a lot better for you.
Yeah, these are all still pretty small instruments. Like if we're talking about 3-inch refractor, I'm using a 4-inch refractor these days. Before the podcast, I was talking about my 6-inch Maksudov, but apertures between 3 and 8 inches or so. These are definitely the small telescopes in which are really the main ones in the hands of the amateur astronomers. And I think they provide really the best views that you're going to get visually through through a telescope. But you've been collecting some pretty fancy, or maybe fancy is the actual opposite word. You've been collecting some very basic but expensive eyepieces for Mars. Some of those monocentrics, and have you been able to use those on the planet yet?
No, I actually haven't. I was hoping the other night when we were out, I brought them, but the
Yeah,
seeing was so bad it didn't, it wasn't
yeah.
worth bringing them out.
I did bring my XO, and I meant to use it because the better monocentrics and very minimal eyepieces and the higher quality ones will actually give you a better view in those poor seeing conditions.
Yeah.
Like,
Well, I've even noticed that in like good conditions.
mhm,
If I put the super mono in over, say, my Leica Zoom,
yeah,
the conditions go from, say, like a 3 out of 5 to like maybe a 3.5 out of 5. It seems
yeah.
it just gets better. Um,
So, because one thing I was observing here a couple weeks ago was through my XO, I could see this sort of the white area of the North Polar region, and I could see like this blue line. But I thought it was like remnant chromatic aberration in the refractor. But oddly, I could only see it in the 5.1 XO, and I couldn't see it in any other multi-element like larger field eyepieces. And then when I was chatting with really an amazing planetary observer, Richard, he was saying that that was the atmosphere, and had an image that he had drawn and sketched and sent to me, and I was like, yeah, for sure, 100%. Like that's what I was observing. But again, like you're really getting down to some pretty fine observations with some pretty expensive little eyepieces,
mhm.
as well. Like filters can really help quite a bit. I've been using the number 21 orange,
Okay.
and I've been using a filter made out of optical glass, which costs a little bit more than just like the generic filters that you buy, and a contrast filter. And you've actually got one of these salmon filters. I had salmon last night, but this is a salmon colored filter.
Yeah, yeah.
I know you're a fan of salmon as well,
I
so but
love
I
my
did have
salmon.
salmon
Yeah.
last
Yeah, yeah. I think it's like a Ratten 30 or
night.
32.
Okay.
Also magenta, I think is how it's listed. Um, yeah, it's wonderful too. Like it's I'm trying to think here how I would place it.
I have
It's
the Sorry, go
Go
ahead.
ahead. I was
Yeah.
just going to say it's not quite like as deep in terms of color as the 21 orange.
Yeah.
It's lighter. I'm just reading here. So the magenta enhances red and blue features, improves
Hmm.
polar region features, some clouds and surface features. If you read on cloudy nights, a lot of the planetary guys, especially the Mars folks, really they seem to gravitate towards that one a lot.
Yeah. I also have the Celestron Mars filter, and I
Yeah,
like that one quite a bit.
yeah, yeah.
It's quite
Yeah,
nice.
and what filters do is, they'll block certain wavelengths of light while allowing others to pass. So the reason we use these filters is because it may expose a certain feature or allow us
Yep.
to see just a little more detail on, say, the darker region or the polar region, or sometimes you'll get a band of clouds passing. So, we'll try these different filters to pull out a little more contrast and specific details.
Yeah, and the other thing that I noticed, especially when the seeing, we didn't do any of this the other night because I think we were just really enjoying like being together and sort of observing once again under the sky
Yeah.
with our very, very small. Um, Bubble group or when dip wavelengths of light aren't being impacted by the bad seeing when they're occurring.
Yeah.
So sorry, I had just a small hiccup in my internet connection there.
Yeah, I was just going to text you.
Yeah, I think I
Something
just
happened there.
dropped out for a very brief moment, just a breather, just a
Yeah,
breather.
yeah,
So I think what it comes down to, though, with Mars, sort of, fortunately or unfortunately, the more you look, or perhaps in the case of like Lowell, the more you'll imagine you'll see. But really, it is a business of going out and observing quite a bit.
hmm
I think to really see a lot of this stuff. Otherwise, sit back and enjoy the Hubble images or whatever kind of other space telescope or amateur images roll in over the coming next couple of months.
yeah. Totally agree. Time at the eyepiece is essential. Something else that can help though is to research a little bit of the surface features and what is possible to see,
Yeah.
because that helps you look for things, right? To see if you can see Olympus Mons, for example, if it's visible on the night that you're observing.
Yeah, and then as well, like being a member of an astronomy organization, we're members of the RASC, and then we have sort of some partner organizations like with the ALPO, the Association of Lunar and Planetary Observers, and so Richard Smoody, who's a member of both, he's on some of the same lists I am. So I think he's like the director or associate director of the Mars section or something like that. So great person to chat with. There's a lot of other sort of more experienced visual observers, and sometimes they're just using slightly larger equipment. So I was using my 60, and if they're using like he was using a 6-inch telescope, and then somebody else is using an 8-inch, and we are kind of going back and forth a bit. So the stuff that's just at my threshold that I'm not really sure I'm seeing, they're getting it a little bit sharper with like a 6 or an 8-inch scope. But yeah, you're right. I mean, even with really small 60 millimeter or 3-inch telescopes, even you're really able to see quite a bit.
For sure. And it's an easy planet to find as well now in the night sky. It's not like Uranus or Neptune. You can't miss Mars right now.
No, like you walk out, even this morning, it's not totally cloudy, but there's a really thick layer of cloud preventing you from seeing the majority of stars in the sky. I think maybe I could see like a couple of the other brightest stars, like I could see the moon and Venus shining through. But then Mars is like sort of the third brightest thing up there right now. Just phenomenal to see.
Yeah, yeah. I'm looking forward to the next couple months.
So, have you done any reading on Mars?
A little bit.
It's really hard in the spacesuit. No, I'm just kidding.
Yeah, I've talked a little bit about this book that I recently got. It's new to me, but it's an old book, and it's called Moon, Mars, and Venus: A Concise Guide in Color. Hamlin is the author. So the majority of this book is maps of the moon,
Okay.
drawn by Ruckel, which is pretty cool. But there is a 10 or 15 page section on observing Mars, which is pretty good. It's a little dated, but things, what is talked about here absolutely applies today. And it's a handy little book. I like it a lot, actually.
Yeah. And one of the things is that as far as like the visual observing, which is what you and I are mostly interested in talking about and looking at for ourselves, hasn't really changed much in the past 50 or 60 years. So, reading some of the older material is really enjoyable and a lot of fun, because most of the missions now, like you're looking at rovers that are scouring the planet, and you're able to look at a close-up image of a rock core sample that's been drilled on the planet. Well, you're never going to see anything like that through a telescope, like not even close, or like the Mars Reconnaissance Orbiter or anything like this. Like they're taking such high resolution images. You can see like these sand patterns on the surface. You're never going to see anything like that through a backyard telescope. So pretty much everything that you're going to see was more or less known about since about the 1950s or earlier, for the most part. There's a few things, but I think that's a fair assessment.
Yeah. One of my favorite things that I use, Chris, is it's Orion's Mars map.
Okay.
I don't know if you've ever looked at it.
I haven't.
I put a link in our notes there if you want to check it out. But
there it is.
It's just like a 3-page folded, almost like a brochure. It's laminated, so this is meant to be beside you at the eyepiece, and if it gets wet with dew, it doesn't really matter.
Okay.
What I love about this thing, you open it up and it gives you, it's a map of Mars, so you get kind of both sides that are largely visible to Earth, with all of the major features plotted. So it plots 150 features. Now, what I love about it is it also gives you the size of these features, like the width. So depending upon your aperture, if you can only resolve something down to say 300 kilometers wide, you can kind of scan through the list to see what is visible within, your aperture that you're using.
Wow.
So that's really cool.
But is cool.
About
I'm just looking at it here.
Yeah, like it talks about like the clouds and hazes, and it gives you a little bit of an overview as well as how to observe it. It talks about using different filters. And it gives you a list of all the Ratons, like 8 through 82. And then it tells you, like, for example, Raton 12, deep yellow, brightens desert regions, darkens blue and brown features, enhances blue clouds.
Yeah.
So you have a little bit of a reference there for which filters will help bring out different things.
Hmm.
Talks about the seasons, the caps,
Wow.
conjunctions, oppositions, and it's like $20. And it's
It's
probably, in my opinion, the best thing you can have for observing Mars
Yeah, I
at the
see. Like,
telescope.
yeah, it's actually $13 American. The whole kit is $30. Maybe I was looking at this kit before. I just wasn't sure how good it was, and maybe I just never knew you actually had purchased it. It's through Orion Telescope and Binocular. If they wish to sponsor the show, that'd be great.
Yeah, I'll tweet out a picture of the cover
Yeah,
just so everybody has that reference. But yeah, highly,
yeah,
highly recommended.
yeah. Wow, cool. Well, sort of on that note, I have a little bit of a longer reading list here with stuff that I've been really enjoying. Um, so I have one book that I really think is very good. It's by Patrick Moore. It's called Patrick Moore on Mars by Patrick Moore. And the reason why I like this, it's a super easy read, and it's quite enjoyable. He talks about like sort of the history of observing Mars and some of his observations, and then sort of like later on gets into some of the space missions and such, which is much dated now, being a 20 or so year old book. But like I said, for the most part, about 80 or 90% of it is on the history of Mars and his observations, and all that is still relevant today. So that's Patrick Moore on Mars. I think probably the easiest and most enjoyable read. I have another book that I've read most of this summer. It's a little bit academic. It's by William Sheehan, and it's called The Planet Mars. It's actually available online as well. I'm not really sure why. I think it must be out of press, and maybe he's agreed. I'm not going to send out a link to it in case there is an agreement on that, but just called The Planet Mars by William Sheehan. And it's he goes into a lot of the sort of history and a bit more of the details on the individual observers. It's a good read, a little bit more detailed, and a little bit more academic. And then sort of on the technical side, sort of like the technical observing of Mars, is Mars and How to Observe It by Peter Grago, who unfortunately passed away a few years ago. But this is from 2012. So I think that's sort of the more recent. And he goes into a lot of detail on what you can see in different apertures and the equipment to use. And it's a very comprehensive book. I really like it. It's not a book you're going to read cover to cover, though. And there's some stuff in there that is extremely technical. I really like Peter Grago's works. He's done a few of these books, but they are comprehensive. I mean, and he goes into the history as well. But it's one of those books. It will grow. You will grow with the book. There's a lot of stuff in there that I enjoy reading now that I didn't when I first got the book 7 or 8 years ago. Then this other one, this is one I read this year. I'm not sure. This just came out in 2016. It's not a book. It's an academic paper from the Society for the History of Astronomy. And it's again by William Sheehan. It's called Mars, The History of a Master Illusionist. And it mixes psychology and astronomy. And that is a fun read. That is a really, you should, and it's not that long. It's a paper. And I think you should read that one, Shane. I think you would enjoy it.
Yeah, I'm just checking it out right now.
Yeah, it's approachable actually, and that's just a paper that's freely available online, so there's no cost to it. But I think if somebody was just looking to pick up a general interest book, Patrick Moore on Mars by Patrick Moore is very approachable. There was a lot of copies put out. Like I bought mine for $2.99.
Oh wow!
So it's very inexpensive. It's a very easy read. Like I've read it every Mars opposition since 2003, because I can read it over the course of about basically a chapter a night, and however many chapters there is. It takes me a week or 10 days, and just reading a chapter at night before bed is really a lot of fun.
Yeah, I'll have to check that one out too.
Yeah, very cool. Well, that's sort of our Mars opposition episode for the Mars opposition coming up on October 12th. But if people are, they should be able to take their telescopes or binoculars that didn't want to watch the retrograde action out to observe it immediately and start observing it.
Yeah, I can't wait.
Yeah. Anything else to add, Shane?
That is all, my friend.
Excellent. Well, we shall end it here. How can people stay in touch with us?
You can find us on Twitter. We are at Actual Astronomy. You can email us, actualastronomy@gmail.com. And you can leave us feedback on any of the podcast platforms. We definitely appreciate the feedback, any and all. And if we can respond, we will respond.
Thanks so much, Shane.
Thank you, Chris, and thank you, everybody, for listening.